Hello and welcome to the session. In this session, we will discuss about trees and traversal trees. In graph terminology, we had discussed about digraphs and basic concepts of graph. Now using it, we will discuss about trees. A tree is a connected, undirected graph with no simple circuit, no multiple edges, and no loops. An undirected graph is a tree if and only if there is a unique simple path between any of its two vertices. A tree with n vertices will have n-1 edges. If a graph is not connected, then it is not a tree. Now let us discuss rooted tree. A rooted tree is a tree in which one vertex is specified as a root such that there is a unique path from the root to each vertex of the graph. We direct each vertex away from the root. See the following tree. Here, A is the root. If V is a vertex other than root, then the parent of V is the unique vertex U such that there is a directed edge from U to V. Here in the graph we can see that D is a parent of F, G and H, and also root A is a parent of D. Now, if U is a parent of V, then V is called a child of U. So here, as D is a parent of FGH, so FGH are children of D. Similarly, D is a child of A and E is a child of B. If two vertices share the same parent, then they are called siblings. Like we can see in the graph that FGH have the same parent D. Vertices with no children are called leaves or external nodes. The vertex C is a leaf as it has no child. Similarly, the vertex G is also a leaf. Vertices with children are called internal vertices. So here D, E, B, F, H are internal vertices as they have children. The ancestors of the vertex other than the root are the vertices in the path from the root to this vertex, excluding the vertex itself and including the root. See here, in the path A, B, E, I, A, B, E are ancestors of I. The descendants of vertex V are the vertices which have V as an ancestor. Again, in the path A, B, E, I, E and I are descendants of B. The level of a vertex V in a rooted tree is length of the unique path from the root to this vertex. Level of B is 1, level of J is 3 and level of F is 2. The height of rooted tree is the maximum of all the levels of the vertices. If V is a vertex in a tree, then the subtree with V as its root is the subgraph of the tree consisting of V and its descendants and all edges incident to these descendants. The vertices B, E, I, J form a subtree. Ordered rooted tree. An ordered rooted tree is a rooted tree where the children of each internal vertex are ordered. For example, in an ordered binary tree, which is just called binary tree, if an internal vertex has two children, the first child is called the left child and the second child is called the right child. The tree rooted at the left child is called the left subtree and the tree rooted at the right child is called the right subtree. Ordered rooted trees can be defined recursively. Let us now discuss tree traversal. Procedures for systematically visiting every vertex of an ordered rooted tree are called traversal algorithms. The three common traversals are pre-order traversal, in-order traversal, and post-order traversal. Let T be an ordered rooted tree with root V. Let T1, T2, T3 and so on till Tn be subtrees of V from left to right. To determine pre-order traversal, first visit V, then visit T1, then visit T2, then visit T3 and so on. In the end, visit Tn in pre-order. For example, we have the following tree. Now we determine its pre-order traversal. First vertex is root, that is A. From left we have this subtree from vertex B. So here pre-order is B, E, I, then J. Next we have C. Next we have subtree at D. So we have pre-order D, F, K, then G, then H, then L, then M. So the pre-order traversal is A, B, E, I, J, C, D, F, K, G, H, L and M. Here we have moved from left to right. Now let us see what is in-order traversal. To determine in-order traversal, first visit T1 in order, then root V, then visit T2 in order, and so on. In the end, visit Tn in order. Again, considering the same tree, we determine its in order, visiting first subtree and starting from I. We have I, E, J, B, A, C, K, F, D, G, L, H, M. So this is the in-order traversal of this tree. Now let us see post-order traversal. To determine post-order traversal, first visit T1 in post-order, then visit T2 in post-order, and so on. In the end, visit root V. Again, considering the same rooted tree, we will determine its post-order sequence, starting from left subtree from down to moving up from left to right. We get the sequence I, J, E, B, C, K, F, G, L, M, H, D, A. Thus, in this session, we have discussed about trees and traversal of trees. This completes our session. Hope you enjoyed this session.